All right, picking up this time with number 29, which again, I'd like to remind you that the odd problems, you do have Calc Chat available to you in which you can talk to a live tutor. So if you are ever stuck on these, you've got a lot of resources out there. All right, so a man 6 feet tall walks at a rate of 5 feet per second away from a light that is 15 feet above ground, see figure. So this is going to be my 15. The guy is 6 feet tall. This man, I'm going to call him Mr. Lakin. So Lakin is walking at a rate of 6 feet, 5 feet per second. When he is 10 feet from the base of the light, at what rate is the tip of his shadow? So his tip of his shadow is out here. At what rate is the tip of his shadow moving when he is 10 feet from the base of the light? So I'm going to call this the x value, I guess. Actually, I'll call it the Lakin value, L. I think in my answer key I had an x, but it doesn't matter. This is Lakin walking. So I want to know how far this red dot has moved. So I'm going to call this y, because I don't know what it is, in which case this is going to become y minus L from our geometry days, thinking about our, why can't I think of it? Oh, segment addition postulate. Those are the words I was looking for. So if I think about this, I need to somehow, we want to relate the tip of his shadow moving. So dy dt equals question mark later when L Lakin is 10 feet from the pole. So I need to figure out something that relates Lakin and y. Well, if I look at L and y, I should hopefully see something with some similar triangles going on. So I could say that 15 is to y as 6 is to, in this case, y minus L. Okay, thinking about proportions, 15 is to y as 6 is to y minus L. Similar triangles because of these angles going on. Okay, so I'm going to cross multiply. I'm going to get 15y minus 15L equals 6y. I'm going to get 9y equals 15L. I now have a nice relationship between y and L, my variables that I wanted. I'm ready to take the derivative with respect to time. So I'm going to get 9 dy dt is equal to 15 dl dt. Well, if you notice, now it's later, and does it even matter that we're 10 feet away? No, it does not. But it's later, so we can sub stuff in. Dy dt is what I'm looking for. dl dt was equal to 5, so 15 times 5 is going to be 75, divided by 9, which ends up being 25 over 3 feet per second is equal to dy dt at that later moment. All right, so when he is 10 feet from the base of the light, at what rate is the length of his shadow changing? Well, now this is interesting. There's a lot of different ways you can do this, which I wrote in my answer key. The length of his shadow is represented right here. So all I'm asking for is the rate of change with respect to time of y minus L. Well, I can just do that. dy dt minus dl dt. I'm just going to take the derivative of each one and subtract them. dy dt, I just found out, was 25 thirds. dl dt, Mr. Lakin walking, was 5. So putting that together, 25 thirds minus 5 ends up being 10 thirds, and that's going to be in feet per second. Okay, again, there's a lot of different ways to do that one. If you got to the 10 thirds, and if you got, oh no, Screencast-O-Matic came up. If you got to the 10 thirds and you got to the 25 thirds, you're fine. Whatever you're doing and how you thought about it and how you related your variables using geometry is totally fine. You don't have to take the same labels that I chose. All right, last one. I'm only going to do I for this. You guys can then use it to do the graph that's 2, I guess, 2I. So how do you see it? Using this graph of f, determine whether dy dt is positive or negative given that dx dt is negative. So here's my x's. Here's my y's. What I know is that dx dt is negative. which means that the change in x over the change in time is less than 0. That's what I wrote on my answer key. So that means that my x's are getting smaller. So here x's are bigger. I'm going to cruise along and talk about my x's getting smaller, I guess in the negative direction. It's asking what is going on with my y's. Well, as I move this way, this point was 4 comma 1/2. This one is 1 comma 1. This would be 0 comma 2. What's happening to my y values? As my x values move to the left, my y values are getting bigger. dy dt needs to be positive because my y's are increasing. So positive slope. As I move to the left, my slope is going up, which is confusing because we don't usually read from right to left, but in this case, they're asking us to. All right, the next one says determine whether dx dt is positive or negative given that dy dt is positive. So in this case, dy dt being positive, change in y over change in time is greater than 0. So my y's need to get bigger. So I'm going to be traveling this way. As my y's get bigger, what is happening to my x's? Well, as y goes up, so here y was 1/2, y was 1, y was 2, y was 1/2, y was 1, y was 2. What were my x values? My x values were 4, and then 1, and then 0. So my x's were getting smaller. One might say they were decreasing. So dx dt was also less than 0 or negative. Okay, so you're thinking about how do you move along the axes. Those of you that have done a little bit of study in parametric, remember any two variables can be related with time. So if I drew a little XY chart for this one, if this helps you to see it, my x's, for instance, if I go from, I'm supposed to have dx dt be less than 0. So I got to start out here at 4, then we'll go 1, then we'll go 0. These were happening at 1/2, 1, 2. So my y's were getting bigger as my x's were going in the negative direction. Okay, again, there's lots and lots of videos. There's also lots of resources out there for related rates. You can Google, you can use Khan Academy. Please, please, please study, study, study.